4xn cubed. Number 3, let's go clockwise. Eli.
4x is 6.
Right, just add the exponents, right? X times x, add the exponents. Okay, number 5, Caden, what will the left parentheses become?
Wouldn't it be 4n squared?
Yeah, 2 squared is 4, n squared. What will the right parentheses become?
N to the 8th.
Okay, and then if we multiply those together?
4n to the 10th.
N times n adds the exponents. So notice when he did n to the second to the fourth, he multiplied the exponents, not added. But at the end, when he did n times n, he added the exponents. Okay, number 7. Anna, with the normal numbers, the 2, the 3, and the 2, what will they become?
18.
2 times 3
6.
times 2.
18.
6 times 2.
Oh. Oh.
12. And then,
Wow, Olivia, you got that?
how many v's do we have? 5. So we're just adding the exponents again. And then how many u's do we have?
9.
7, 9, yep. And then Shannon, kind of the same thing on number 9. What do the normal numbers become? 2 times 4? 32. And then how many m's do we have? 5. And how many n's do we have? 5. So just adding exponents right there.
And then it goes back to normal. And then it goes back to
Number 11.
Mr. Jordan, is Coke your favorite drink? I just need to know.
Dr. Pepper.
It's a tie between Coke and Dr. Pepper. Probably.
That's exactly what I thought.
Okay.
Cool.
We see no Coke.
Just not at all.
Okay. Lisa. So that big parentheses on number 11, everything is squared in that parentheses. So Issa, let's start with 2 squared. What would that be?
To all of it. That's 4.
Just the 2 so far. And then what happens with x to the 0, y to the 0? What's that do?
1.
Well, they turn into a 1, but what's 1 times anything?
4.
That one.
Yeah, it just turns into anything. So the 1's just kind of disappear. So ignore the x and y 0. And then what's y to the 4th to the 3rd?
12 times 2.
And then to the 2nd. Yeah, you multiply. 4 times 3 is 12, times 2 is 24.
Hold on, wait, can you, how did you get that?
When you do y to the 4th,
Oh,
the
wait, I
3rd,
get it. You do the 4 times 2,
yeah.
and then the times 3.
Well, yeah, we did 4 times 3 and then times 2.
Oh, okay, yeah, that makes sense.
Okay, 13. Hope. What do the normal numbers become?
6.
6. And then how many p's do we have, I guess?
8.
4, yep. And then how many r's do we have?
4.
How many q's do we have?
Oh, my eyes are.
1. No, 0.
Yeah, none. All right. You guys count that one. Shh, boys. Macy, on number 15, what do the normal numbers become? 24. And then how many A's do we have? 4.
What do you do for 0 again?
How many B's do we have?
8.
If you're, anything to the 0 is worth 1. But if you multiply by a 1, it does nothing, so it just disappears. If you're doing like a to the 3rd times a to the 0, you're adding exponents, so it's just a to the 3rd. Anyways, how many B's did we have? Sorry.
8.
8. And then how many C's do we have?
1.
Yeah, just 1.
Wait,
Oh,
There's
no, there's
two.
one in the middle and
Oh,
one, right?
oh, so 2?
Yeah, there's two. Alright. Did everybody get one? No, we started there, didn't we?
Yeah, it's me.
There's some problems on the back, but 17, Olivia. What will the left parentheses become?
It would become M4P4, right?
Nope.
What?
You're adding, and you should be more like multiplying. On that.
So just M3P3.
Yes. And then the right one, I'm just gonna write that down. N2, N3. Okay, so what do we have with the normal numbers?
Just 2.
And then how many M's do we have?
6.
Nope.
What? Oh, 5.
Yeah. So here's the thing, guys. If you have M times M, that's adding. If you have M power to the power, that's multiplying. So I think way back when I was your guys' age, I think what I thought was like numbers next to each other in parentheses usually means times, right? So just remember that means times. And the other one is add.
So it'd be M5, then.
How many N's do we have?
But wouldn't we put the P in?
How many N's do we have?
We do the P.
3.
How many P's do we have?
4. 3.
Just three.
Oh my gosh. I'm so
You're
bad.
getting there, Olivia.
Panic.
I'm doing
You're
Panic.
working
terrible.
on it,
Okay, that's the front.
I
On
might
the
as well
back,
drop out.
number 1.
Yeah, I'll just drop out.
Willow, do you remember how to write in scientific notation? How does it start for number 1?
You move to the right.
Grant, stop talking. What?
You would move to the right, so you get 7.86.
Right, the decimal needs to be after the 7. And we always put 10.
And then it'd be -7, right?
And yeah. How do we know if the exponent is negative or positive?
Because if it's a small, really
If it's
small
gonna-
number,
Yeah, if it's a tiny decimal number, it's going to be a negative exponent. If it's a big number, you'll have a positive exponent. A big.
Wait, what?
So, like,
Number 1
would
is
be
a
negative?
tiny decimal number, so it's going to have a negative exponent.
And would 3 be a positive?
3 is a weird one,
yeah, I was
actually.
supposed to say that's.
Well, then would.
Oh,
be
I
like,
put 19. Whoops.
But I'm still.
3 is a weird one, and it's going to be Forrest's problem. Okay, Forrest, what do you think for number 3?
4.7 of that times just 10.
Nope.
The zeros.
And it-
Oh, 10 is
Why is it 0?
because it's 1.
Because the decimal's not moving. Yeah. 10 to the 0 is like multiplying by 1, and it just keeps the value the same. This would be an example of a number you would not want to write in the scientific notation, because it just makes more work. Really, it's for giant numbers, not normal numbers. Okay, anyways, number 5, back to Grant. We made it all the way around. How do we change 0.06, Grant?
Is it 0.6 times 10 to the -1?
No, because the decimal has to go after the first non-zero
Oh,
digit.
so it's just 6 times 10 to the -2.
Yes. It has to go after the first. So it's always going to be like 5.3, 1.8, 9.7, just one digit and then the decimal. Or 6.0 or 6. Okay, Eli, number 7. What does standard notation mean?
It's like, right, it's got all its zeros.
Yeah, it means normal numbers. So how do we, without it, okay, if you want to use a calculator on the evens, that's fine, but how do we do it without the calculator?
Move the decimal point, how many times it has
Right, move the decimal 3 times, but which direction are we going? If I multiply by 10 to the 3rd, is that going to make my number get bigger or smaller? Bigger. Yeah, that's like multiplying by 10 3 times, right? So that makes the number bigger. So which way should the decimal move for the number to get bigger? To the right. So what does it become?
6,170.
Yeah. 1, 2, 3, 6, 1, 7, 0. 6,170. Just move the decimal 3 places to the right. Number 9, Caden. Okay, let's say it this way. We got to move the decimal 6 times. How many zeros, Caden, is number 9 gonna have?
4.
Okay. You guys know why there's only 4?
No.
Because
Okay.
it started off in the 7.
Right. Here's where the decimal was. So 1, 2. That just gets me past the 1, and then 3, 4, 5, 6 gets me all the way. So the first 2 moves gets me to the end of the number, and then that leaves 4 more moves and 4 zeros. Go. I do want you guys writing the commas in there, so commas help you actually read the number. Because if you just have a bunch of zeros and stuff, you won't be able to tell what it is. 7 million. All right, number 11. Anna, what do you think we're going to do on number 11?
Move it over like. Don't we make it bigger or something? I don't remember.
Well, on the last 2 problems, we have positive exponents. So that moved it to the right and made the number bigger. On 11, we have a negative exponent. So, you guys remember what 10 to the negative third means? 10 to the third means 10 times 10 times 10, right? But what's 10 to the negative third mean? What does negative exponent mean?
You got flip.
Right. So, what's happening is we're multiplying by 1/10 each time you multiply by negative 3 times, which is like dividing by 10 times 1/10 divided by 10. Anyway, you got to move the decimal left 3 times. So, how many zeros, Anna, will this have if we move the decimal left 3 times?
0.067.
So 1, 2, 3. So what do we do with these 2 blank spots?
0.
Zeros. So we got 0.0067. You can put a 0 in front of the decimal if you want for like the whole numbers, but I usually skip that part and just leave it like that. Okay, Shannon, number 13, it says write in scientific notation.
But it's already inside.
2 times that 10 to the 7.
Okay, so what on earth did she just do? So what she did is she moved the decimal 1 place to the right. Did that make the number get bigger or smaller?
Bigger.
Small.
Bigger.
You got it right, and yet you still failed.
Okay, she said bigger, I think.
She said
I
smaller.
said
Oh,
Okay, so it went from 0.2 to 2. So if you make this number bigger, then you, sorry. If you make this number bigger, then you have to make this number smaller.
Wait, did I get it
Oh,
wrong?
yeah, we got it wrong, didn't we? Sorry.
Shut up.
Oh,
I think we still got it wrong.
So it should have been 10 to the 5th. Sorry, I wasn't paying attention.
That's, so was I right?
Or no?
She does. Anna told me the
No,
answer.
well, this number is getting bigger.
I said smaller.
This is getting bigger.
Oh.
So this had to get smaller to make up for it.
I was thinking we were number one.
Okay, 15. Oh, okay, guys, if these last, how many, 10 problems are confusing? Shh. If these last 10 problems are confusing, what's another way that we can find? Okay, calculator. So if you plug in your calculator equals, it'll give you a normal number, and then you change it to scientific like we did on 1 through 6. Some of your, probably, maybe even all of your calculators probably have a scientific notation button somewhere, but it might be hard to find. That could do it, but they're different on different calculators. So anyways, 15, where are we? Isa. 88.4 is going to turn into
8.84 times.
8.84. So did we make that number smaller or bigger? Smaller, so this has to get bigger.
4.
So 4.
Here's your cookie, Wolfie.
Okay, 17. Hope. So these are 17 through 22. They're all multiplied. You guys notice that? Parentheses times the parentheses.
Yeah, that makes it way easier.
So we have to do 5.4 times 7. Hold on.
But you just multiply the
5.4 times 7 is 37.8. And then Hope, what is 10 to the negative 1 times 10 to the 0?
Negative 10 to the negative 1.
If you add negative 1 plus 0, it's still negative 1. And then that's not in scientific notation because the decimal's in the wrong spot.
And then we would go to 3.78.
This number is getting smaller or bigger? Smaller, so this has to get bigger. What's negative 1 plus 1? 0.
Yeah.
Third.
Okay,
Girl.
19. Okay, let's see, Macy, what's 6 times 4?
24.
And then what is 10 to the 6 times 10 to the negative 1?
Oh? I don't know, I'm not in the brain part right now.
10 to the 6 times,
Oh, wait, you're just multiplying, right?
okay,
Oh, adding?
when you multiply the same base, what do you do with the exponents? Add. So what's 6 plus negative 1? Shh.
5 or. No.
Yeah. If you're adding negative 1, you're basically just
Take.
subtracting 1.
Yeah.
So it's times 10 to the 5th. Is that in scientific notation? No. So I'm going to change it into 2.4. Did I just make that number get smaller or bigger? Smaller. So the exponent has to get bigger.
I'm so confused.
Which part? The last part or this part?
Oh,
Both.
All of it. So do you see where we got this from? The
Yeah.
24? Number 19?
Was the 6 times 4?
Yeah.
Okay. But then when you do 10 times 7, what?
10 to 6 times 10 to the negative 1. You add the exponents,
Oh, which would equal 10 to the 5th.
and then that's not in scientific notation, so I turned it into 2.4, which made this number smaller. So to make up for it, I made this number bigger. These two values, guys, are the exact same thing. Did you guys get that? Like this and this are both equal. What's the difference? The difference is this is scientific notation. This is not. That's it. Anyway, 21. Almost everybody got 2 questions, except for Forrest. 21, okay, 7.68 times 9 comes out as, I'll just tell you, 69.12. Plug that in the calculator. And then Willow, what's 10 squared times 10 to the 6th? 10 to the 8. Is that scientific? No. So what does it change into, Willow?
6.92. So 10 to the 9.
Ding, ding, ding.
I did.
Because you're making it smaller.
69, yeah, 69 turns into 6. That's small. So this needs help to get it bigger.
Okay.
I do believe you guys should be able to get this done in
Bye bye
class.
YouTube.